Hey guys, in this tutorial, we're going to look at some potential problems and pitfalls that you can encounter as you try to make this part of exercise 1. And there really are two major pitfalls that I'm going to cover here. One of them is the problem of mirrors, and the other is the problem of concave objects. Okay, both of those are things that I think many of you might potentially encounter as you start to do the second part of the exercise. And they actually cover two interesting conceptual things, so I want to go over those right now. So we're gonna go ahead and start out with the with the problem of concave objects, and then we'll look at mirroring afterwards. In order to do that, I've actually created a new object. In this case, it's just that same 4x4 box, but you can see it has some sort of surfaces that go into the object. So it's like almost like cutouts of it, right? But that are themselves have surface, right? So there we see them, right? And so at this point, everything is one continuous polysurface, and you guys will see now if I grab this object and I type unroll surface and I press enter, you get this. And when you get this, some of you guys might get, obviously it might not be quite as organized because you don't have necessarily objects that are orthogonal, but you might get something like this where there are surfaces on top of surfaces. And this actually, you might say, oh, something went wrong, but this is actually correct, right? And when we stop and think about it, it makes a lot of sense, and it happens almost every time that we have a concave object, right? And that's because if you try to think about unrolling this sort of cutout, right? When you unroll that cutout, it kind of, the flaps of it, this piece and this piece and this piece and this piece would overlap with this larger surface that they sit on, right? And so if I grab this and I explode it, I can sort of see that this and this and this and this, those four, are those four flaps, right? That would go, and in this case, it actually folded, but they would be right there, right? I would even have to rotate those, and they would be essentially those flaps that would go right there, right? So you'd imagine that one goes there, that one would go here, right? And so on and so forth. So you could see how actually anytime we have one of these kinds of problems, we would get this sort of overlap of surfaces that would look something like this. And you guys will see they all match up perfectly. And if I grab this and I rotate it as well, just 90 degrees, right? We can see how it will match perfectly. And so really it's more like we would have to grab all these surfaces, these 5, and move them out of the way, right? And so these 4, with this edge, this edge, this edge, and this edge are what are going to align to this, 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 and this, and in order to produce that inset object, right? And so we could see how the same thing would happen here. And so like one of the other ways that you could think about it is you would just have to displace all of these, right? Build this portion, and then after you've built this portion, attach it into this surface and inset into it, right? So that covers the first problem. You might not have this exact same solution for it, but in every case, anytime that you have sort of surfaces that are overlapped on top of each other, it's because essentially what's happening is geometrically those surfaces, when they get unrolled, take up the same physical space on the XY plane. They essentially sit on top of each other. And that's because then when you bring them together, they create some kind of inset corner. Okay, So if you have something like that, nothing to worry. Just remember, you have to move them off of the plane of each other. So put them beside each other, and now you're ready to go on to that step of creating the templates. And so in your case, you would have 3 templates that you would cut out and put them together and then tape them at all the seams, and you'd be able to reproduce that object. Okay, so that is the first potential pitfall that you might encounter. I'm going to go ahead and move this out of the way. And the second pitfall that many of you will encounter is that as you start building your object, you will realize that all of a sudden it doesn't, you're taping it together, everything seems to align and work, and you finish putting it together, and yet when it's all closed up, it doesn't look the same, doesn't look identical to your 3D model. And the reason for that is because of the mirroring problem. And if I just, to demonstrate, if I just mirror this object based off of this axis, right? Now I have this and this, or for example, if you guys look at your own 2 hands, your hands are essentially mirrors of each other, right? What's really fascinating about mirrors is that geometrically, they're actually different and distinct objects. So if I grab this and now I try to rotate it 90 or 180 degrees to get it to line up with this one, right? It won't line up, right? You see here the holes are in opposite places, right? And no matter what you do and which way you try to rotate this object, your mirror is always geometrically distinct from the original object. It is a mirror image. It is not the same. And so you will never be able to put it back together, right? So why is that relevant? Well, because when you decide to unroll, you can unroll in 2 directions. You can unroll, and I'm gonna explode this, and you can, to show you, but you can unroll like this, like I showed you with that original box, off of this axis, right? And downwards, and in which case the inside of the box, what was on the inside portion of the surface, is now facing up, and the outside is facing down, right? So that's one way in which you can unroll it. Or the other way that you can unroll it is actually if you rotate this off of the top. Then you rotate like this and unroll like this, in which case the outside is facing up and the inside is facing down, right? And actually those 2 things, those 2 ways of unrolling produce mirror images of each other. And so when you type the unroll command, Rhino doesn't necessarily know which way is up and which way is down. And so when it unrolls, it might create the inverse. It might create the mirror of your object. And so when you're doing that, you know, if you just click unroll with a random object such as this one where we had back here, you should actually grab your object and type mirror and mirror it and also print out this version of it, okay? And so that way when you fold it, and if you start realizing that you're folding it and it's starting to look like the mirror of this object, then you know that you actually just grab the wrong template essentially, and you can grab your other version and start building off of that one. And so those are your main 2 pitfalls, the mirroring problem and the concave surface problem. Both of them are actually really fascinating because they point to some just truths about geometry and about the way objects behave in the world. And so both of them are good moments to realize about a little bit about the world we inhabit. And that's it. Those are the 2 main ones that we'll cover. If you have other problems, they probably are pertaining to printing or scaling, and those are things that I think you guys can figure out on your own. So we will leave it at that. Thanks, guys.